This is the solution to number 5 on the 2000 exam. So our first part is to show that our derivative of this curve is this guy over here. So part A, we're first going to use the product rule. So first derivative of the second plus the second, and the derivative of x is just 1, minus, we're going to use the product rule again, but we need parentheses. First derivative of the second plus second derivative of the first is equal to 0. All right, I'll distribute my negative. So I've got 2xy and now minus 3x squared y. So I'll put every term with a dy dx on the left. I'll keep it on the left. And all other terms to the other side. So we'll have 3x squared y minus y squared. So dy dx equals 3x squared y minus y squared over 2xy minus x cubed, which is good because that's exactly what we set out to show the derivative is. So part B, we want to find all points on the curve whose x-coordinate is 1, and then write an equation for the tangent line at each of these points. All right, so part B, we want x equal to 1. So the curve that we're given looks like this. Oops, minus x cubed y equals 6. Now if x is 1, and if we bring the 6 over, we get this. Which means we have two coordinates with an x value of 1. One of them is 1, 3, and the other is 1, negative 2. So now the second part said that we have to write the equation of the tangent line at each of those points. Okay. So we've got y minus 3 equals the slope times x minus 1, or over here we've got y minus or plus 2 is equal to the slope times x minus 1. Now we're going to find the slope using our derivative. So the first time we use x is 1, y is 3, and then for the second line we still use x is 1, but y is negative 2. So here the slope is equal to 3 times 1 squared times 3 minus 3 squared over 2 times 1 times 3 minus 1 cubed. So this is 0, which means we have y minus 3 equals 0 times x minus 1, or we can just say that that is y equals 3. Over here, we have 3 times 1 squared times negative 2 minus y squared over 2 times x times y minus x cubed. So this is negative 10 over negative 5, which is positive 2. So this line looks like that. And now finally for part C, we've got to find where our tangent line is vertical. So we set our denominator equal to 0. We can factor, and we get that x could be 0, or that 2y minus x squared could be 0. This means that y would be equal to x squared over 2. Now, if you look at the curve, here. If we substituted x equals 0, notice that we'd get 0 minus 0 is equal to 6, which we know is not true, which means that there is no point on the curve where x is equal to 0. But we have this other guy over here, this y equals x squared over 2. So let's substitute that in. Here's our curve. And y equals x squared over 2. So we've got x squared over 2 squared, x cubed, and then again x squared over 2 equals 6. So this is x to the 5th over 4 minus x to the 5th over 2 equals 6. So we have negative x to the 5th over 4 so x is the 5th root of negative 24. And this is the x coordinate where our tangent line is vertical.